In many AI projects, especially those dealing with large volumes of data like insurance claims or fraud detection, it's not enough to ask, how accurate is the model? Accuracy alone can be misleading, especially when most of your data belongs to one dominant category. Imagine a fraud detection system where 98% of the claims are legitimate. A model that simply predicts legitimate every time would still be 98% accurate, but completely useless. That's where AUC, or area under the curve, comes into play. AUC refers specifically to the area under something called the ROC curve, which stands for Receiver Operating Characteristic. At first, the name might sound like a relic from radio engineering, and in fact, it is. But its value in AI today is undeniable. AUC tells you how well your model separates the yes from the no, the fraud from the legit, the healthy from the sick, across all possible thresholds. Let's break that down. Most classification models work by giving you a probability. For example, there's an 82% chance this claim is fraudulent. You then pick a threshold, say 0.5, to turn that probability into a decision. Anything above 0.5 is considered fraud, anything below is not. But what if 0.5 isn't the best cutoff? What if you want to be stricter or looser? The ROC curve helps you explore that. It plots the true positive rate, the percentage of actual frauds your model correctly catches, against the false positive rate, how often you wrongly flag something legitimate as fraud, for every possible threshold. And the AUC is simply the area under this curve, a single number that tells you how good your model is at distinguishing one class from another. An AUC of 1.0 is perfection. An AUC of 0.5 is as bad as random guessing. In real-world terms, an AUC above 0.9 means your model is excellent. It rarely confuses a fraud for a non-fraud, or vice versa. An AUC between 0.8 and 0.9 is still very good. An AUC below 0.7 is shaky, and below 0.6, it's questionable. Now, why does AUC matter so much in large data models? Because it cuts through the noise. It tells you whether your model is actually learning something useful, or just riding on data imbalance. It helps you compare different models on a level playing field, no matter where their thresholds are set. And it gives your stakeholders a single, meaningful number to guide decisions, not just a percentage that can hide bias or blind spots. Take a real example from the insurance world. You build a fraud detection model trained on millions of claims. Fraud is rare, just 2%. If your model has an AUC of 0.92, that's a powerful signal. It sees patterns that distinguish fraud from non-fraud, even in an ocean of legitimate claims. AUC won't solve all your modeling problems, but it will help you avoid false confidence, and make smarter choices in deploying models that actually work in the real world.